All right, number 42. Refer to the following graphs to determine an appropriate response. Which one is discontinuous over its domain, and what is its range? Simply put, to be continuous, you have to be able to draw a graph without lifting up your pen or pencil from the paper. If you have to lift up your pen or pencil in order to draw the graph from one point to the next, then it is discontinuous. All right, so what does that mean? Well, if we start graphing here, graph A, well, we set our pencil down and we can start graphing, can't we? Swing around and go up. At no point did we have to pick up our pen from the paper. We were able to graph the entirety of graph A in one continuous drawing. Here at B, again, we can set our pen down and we're going to be able to graph this whole thing without having to lift up our pen from the paper. So graph B is continuous. Graph D, we set our pencil down and we're able to graph without having to pick up our pencil. So graph D is continuous. With graph C, the greatest integer function, however, we set our pencil down, start graphing, and we're able only to graph a certain piece of it before we have to pick up our pencil, move it up, set it back down, and then start graphing again. Then we have to pick up, move our pencil up, set it back down, and we continue this process. And so there are discontinuities, jumps in the graph at each integer, y integer there. All right, so graph C is the graph that is discontinuous over its domain. And what is its range? Well, let me go ahead and erase my drawing here. We can see that this graph exists everywhere on its domain. So for all x's, this graph exists. But for the range, rather, the y values, there exist discontinuities. And this graph only exists when the y value is an integer, right? Notice that this graph only exists here at this point, at this piece, when the y value is -3. And then it jumps up and only exists when the y is -2. Or actually, I guess I messed those up, right? This is -2 and -1. And then it jumps up again and exists only when the y is 0. And then it jumps and exists only when y is +1. And then it jumps, exists only when y is +2. So nothing exists in between the y values when the y value is not an integer. So for the range, you can say one of a couple things. Like you can say the range is y such that y is an integer, or you could go ahead and actually list what some of these numbers are, for example. So you could list -3, -2, -1, 0, 1, 2, 3, and continue. So really either way is fine. This here, this ellipse, -3, -2, -1, 0, 1, 2, 3, and then an ellipse, this tells us that the pattern continues and that this is just a small sampling of what the range is doing, right? And we can see from this method of notating the range that each number in this interval is an integer, right? There's nothing that exists between -3 and -2. All right, so hopefully you can see that from the graph that the range only exists when y is an integer.